Hello all. So, we've already seen arrays, we've seen functions, we've seen structures. But in this video lecture, we're going to talk more about mappings. We're going to talk more about your events. Now, what are mappings? What are events that we're going to see right now? So, what is mapping? Mapping is like a hash table. It means every possible key already exists, but may be initially mapped to a default value, usually all zeros in byte representation for the type. So when you see mapping, they declared as mapping key type to value type. Let's say mapping address to the unit, that is your public balances. Every address, every key type, this is a key, and each key maps to a value, the default being 0, and the value type you can specify later. So you can think of it like a table with infinite rows. Any key you query in the table, it is going to have a value. But that value, if not initialized, it is going to be the 0, right? You can think of it like a table with infinite rows, but the blockchain only stores keys you actually assign a value to, saving gas. That is what your blockchain is going to do. But your mappings, they are like infinite hash tables. So mapping syntax, we've already seen mapping underscore key type goes to value type. Key type can be almost of any type except for dynamically sized arrays, except for contracts, enums, structs. Your key type cannot be your dynamically sized arrays, cannot be your contracts, cannot be your enums, cannot be your structures. But your value type can be any type, including your arrays and structures. Now coming to mapping, these are the following things that we're going to see. Declare it, your declaration of mappings, your CRUD. Create, update and delete. What is R for? What is R for? Read. Default values. Exotic mappings. In exotic mappings, we're going to see nested mappings and your arrays inside mappings. Declare mappings. This we've seen already before. Mapping address to uint. That is, address is your key type and uint is your value type. Now then, coming to your CRUD operations, your function foo, that is declared external. The first line say balances message.sender, that is balances. Inside that balances, the balances is your mapping that has been declared the name mapping. Now balances message.sender key, what would be the value? 100. This your assigning value, right? So this is your create operation. Now you're reading the value of your message.sender, the input. That is your read operation. Now you earlier gave that value 100. Now you're changing it to 200. That is your update operation. Then you're deleting it off. Delete. And the next, by default, what? All your keys are initialized to the value of 0. Coming to your exotic mappings. Exotic mappings are simply the mappings inside the mappings or mappings to arrays, which allow your model, model to be more sophisticated, right? To manage the data structures in a more sophisticated manner. In the first one, you see the outer key is message.sender, right? The person sending the transaction. The inner key is spender, the person being approved, and the value is bool, whether the spender is approved or not. So if you see from the very internal parenthesis, the innermost parenthesis, address to bool. Address is your key type. This address is of your spender, and the bool. Bool is your value type. The outermost address, this is your sender's address, right? So you can create, read, update and delete values exactly like a single mapping, but now you have 2 levels of keys. This is very useful when you talk about alliances, when you talk about permissions, when you talk about tracking relationship between users on the chain, right? So in next we have mapping address. Address is your key type. Uint array is your is your value type. So each address maps to an array of values, which are called scores here. The mapping, right? So you can push new elements to the array, you can read elements by index, you can update them, delete individual elements, right? So this is great for storing multiple values per user, like game scores, like transaction history or achievements. Make sense what are exotic mappings? Then coming to your events. Now we're done with mapping, so we're starting with your events. Now in Solidity, now first of all, what is Solidity? Solidity is your language that is used to write Ethereum smart contracts. An event is like a signal your smart contract can send to the outside world. It is mainly used to, communicate the information from the blockchain that is on chain to your external applications, your mobile applications, your web front ends, everything that is outside the chain, the users that are off chain, right? Now, what does it mean when I say an event is emitted? So, you need to think of emit like your broadcast or like, let's say, announce. So, whenever your contract emits an event, it's basically saying, hey, something just happened here and here's the data about it. So write it in the chain. So to emit an event means to trigger it and record its data permanently in the blockchain's transaction logs. These logs are not accessible by the contract itself, but they can be read by external apps like web front ends, mobile applications, which means uh, that your external parties are where these events are being sent to, right? An event is an inheritable member of a contract. That means if one contract inherits another, it can also use the events declared in your parent contract. Now let's say event, we have the event declaration given here, the name new trade. It has uint date, address from, address to, uint amount. So here you're defining an event, let's say new trade. It has 4 parameters, date, from, to, and amount. Think of this as creating a blueprint for a kind of log message you might want to record on the blockchain whenever a trade happens. So it's going to record what? On this date, user X sent Y tokens to user Z. This is what is going to stay on your transaction logs in the blockchain because the event has been emitted. Now, inside the trade function, you emit the event using the keyword emit. When the function runs, this line is executed. Emit new trade now message.sender to amount. What this means? Takes the current time, takes the address of the sender, the receiver's address, the amount traded, and then it broadcasts this data into its blockchain and stores it permanently into its transaction logs. So every time a trade is going to happen, a record of it is going to be made publicly accessible on the blockchain, but not inside the contract. This is going to be accessible through your web applications, through your web front ends, mobile applications, but this data is not going to be visible in your contract itself because this is an events data. Now, if you notice, there's a comment in the event, use indexed for filtering, only 3 indexed in any event. Now, why is this? Because in Solidity, you can mark up to 3 parameters as indexed. Indexed parameters does what? They just make it easier to filter and search for specific events later. Like, let's say, finding all your trades of a certain address or to a certain address without scanning every single entry in the log manually. Now, sending Ether to smart contract, your mapping that is addressed to uint balances. The mapping name is balances. And this line creates up a mapping, declares a mapping, which you can think of as a kind of dictionary key value pair, I would say. Each address is mapped to a uint, in this case, their invested balance. So this mapping, keeps track of how much Ether can each address has actually invested into the contract. If I break it down, so your function, invest external payable. External means this function can only be called from outside the contract. Payable means this function can receive Ether from the caller. Now, if message.value, if the value represents the amount of Ether sent along with the function call, if that is lesser than 1000, WEI. WEI is what? Your smallest unit of Ether. If this is less than 1000 WEI, then revert the transaction. If it's valid, then we update the mapping by adding that amount to the sender's balance. Balance is message.sender plus equal to message value. But if it is less, we do not take it up. We revert it, right? The state gets back to the previous state where 1000 was not, where any amount that was less than 1000 wasn't sent. So every time someone invests Ether, their contribution is recorded under their wallet address in the balances mapping. Makes sense? The next function, balance off. This function simply returns the total balance held by the contract itself. It gives the Ether balance of the smart contract's address on your blockchain. Now, sending ether from a smart contract to another contact or to another contract or address. This is going to be the last slide of this video lecture. With this, if you have had any confusions, any issues, you please make sure that you're letting me know about those concepts to be reclarified in the comment section or maybe in the G forms attached, right? With that, I will make sure that I'm making useful content over them, or I'll try my best to make reclarifying videos on it. With this, if you were able to understand the video, extract 10%, 20% of the video, just go in, like the video, and subscribe to the channel. With this, let's start with sending either from a smart contract to another contract or address. So this creates an address of, if you see, this the address payable recipients, right? The payable is an array because I see the square braces there. So this creates an array of payable addresses. Payable means they're able to receive either. They are allowed to receive either. Without the payable keyword, you can't send either to any address in the smart contract, right? So it's like this is the valid address. Now all these recipients are the valid addresses that can receive money. Make sense? Okay, so function send either address payable recipient external. Recipient dot transfer one ether. This transfers exactly one ether from the contract to the recipient's address. Transfer automatically throws an error and reverts the transaction if the transfer fails. It also forwards a fixed 2300 gas to the recipient, just enough to receive the funds, not execute heavy code. Okay, this is what your transfer function does. Then you have address A means recipient, A transfer one ether. So what happens here is you're first creating a new variable A of type address, right? Then you assign the recipient's address to it. But since A is just address and not address payable, you can't actually transfer ether with it unless you explicitly declare it as address payable. Make sense? So this in your modern Solidity versions, this is going to throw up a type error that is going to say transfer is not available in this address. Message.sender refers to the address that called this function. So this line sends one ether back to the sender. Again, transfer reverts if it fails. So if you call this function, this line would send one ether from the contract back to you. Make sense? Now where the difference is, send also tries to send either, but unlike transfer, it does not revert if the transaction fails. Instead, it returns a boolean value. So if send fails and you don't check its return value, you don't go in manually and check its return value, you may silently lose that ether transfer because it's not going to revert the call, right? That's why send is generally not recommended for the newer code developers. With this, I am good and I shall take your leave. Thank you so much. Bye bye.